Okay, everybody, real quick, for the hours that didn't quite get to these examples, I apologize. Just sometimes they run long. Like the beginning of year stuff is just so plentiful. We're trying to get so much in there, okay? And so the point of the notes today was really to expose you to the midpoint distance, but also help you understand that these are not just like arbitrary things, but instead are skills that have purpose. And those purposes have to do with congruency and finding bisections and midpoints. Now, having said all that, is there also just an arbitrary use of these midpoint distance formulas? Yes, absolutely. In fact, this first example is one of those one of the ways that it is completely arbitrary. So in this example, we were just trying to find the midpoint and distance of some arbitrary segment that has these endpoints. Now, even though we don't have a grid, it's probably a good idea to have a picture. And so I'm just going to sketch out a quick facsimile of what what the segment can look like. And so at least we have a visual that we can kind of attach ourselves to, right? So we want the midpoint, we want the distance. Let's just start with the distance. I think that's probably the easier of the two because like in the end, we just have a direct formula. Now I've been using this form of the formula on the notes and on the key because in the end, if you're subtracting out the x's or subtracting out the y's, you are just actually finding how far apart the x's and y's are. Let me demonstrate what I mean. So if you look at our endpoints, our x's go from -5 to -8. Well, we can take -8 and then add -5. So in other words, -8 plus 5, and get a total distance, or total value of -3. And that's the same as if I go in the other direction. If I take -5 subtract -8, that's going to be a -5 plus 8, or a total value of 3. But if you actually think about like number line stuff, -5 and -8 are just 3 apart. And so whether you do the subtraction or you just like take the change in x to be a total of 3, it amounts to the same deal. Okay? We can again play the same kind of deal with the y's. The y's start at 10 and end at 14, and so those are 4 apart. And so I think we can just take 4 and then square it. Again, if we take like 10 minus 14, that's going to equal -4, and then we'll square that, and that should be the same as like 4 squared. Or if we reverse it and take y1 minus y2, that's 14 minus 10, which would be 4, and then square it. Okay, that will also be 16. So whether I think of this as a distance or I do like the actual subtraction of y1 minus y2, it amounts to the same. Either way, we have 3 squared is 9, 4 squared is 16. That's going to be the square root of 25, or just going to be 5, and which will give us our total distance of AB. In terms of midpoint, again, we can kind of attack this a couple different ways. The midpoint formula is perfectly fine, and so if I want the x value of the midpoint, I'll add the 2 x values together and divide by 2. If I want the y value of the midpoint, I'll take the 2 y values, add them together, divide by 2. Okay. And so for the x values, that would be -5 subtract 8. -5 minus 8 will be -13. Divide that by 2. That'll give us -6.5. On the y values, we have 10 and 14. So 10 plus 14 divided by 2 would be 24 over 2, which would equal 12. And so the coordinates of my midpoint, so the xm, ym, it's going to be -6.5, comma 12. Okay? And so if we stick that here in the middle, okay, we can see that answer is quite reasonable. Because if I go from -5 to -6.5, I'm dropping 1.5 values. If I go from -6.5 to -8, I'm dropping another 1.5 values. So again, it's going down by the same amount. At the same time, 10 to 12 is plus 2, 12 to 14 is plus 2, and so that's definitely going to be my midpoint M. Okay? And so again, like this is the type of problem you're expected to do. Very straightforward, maybe somewhat arbitrary. This is like the one that was really the weird one, and really the one that's important to know as a big variation, because you will be responsible for this type of problem as well. Okay? And I would claim there's 2 ways to approach it. So please understand the big variation here is that you're not given the endpoints. Uh-oh, board messing up. But you're not given them endpoints. Instead, you're given one endpoint. And then you're given one midpoint. Okay, and so your job is actually to find the other endpoint. Okay, and so think about all the stuff we did today, 2 approaches. One would be graphical, visual. The other would be calculation based. In other words, 1, we can just count it out, and 2, we can calculate it out. Okay. If you look at the change in y, 1, 2, 3, 4, 5, 6, 7, we're going down 7 units. While at the same time, we're moving change in x, 1, 2, 3, 4, 5, 6, we're moving back 6 units. Okay, and so if I just double that motion, if I go down another 7, 1, 2, 3, 4, 5, 6, 7, and then over another 6, 1, 2, 3, 4, 5, 6, I should get the other endpoint b, which is given to be 1, 2, 3, 1, 2, 3, 1, 2, 3, 4, 5, 6. So -3, -6. At least that's what it seems to be, although I should have some pretty good confidence since everything is collinear. Remember, collinear means everything lines up. Now, if you don't trust that, or maybe like you don't really see the counting method too well, we can simply use the equation-based method. And so remember, the x value of the midpoint is defined to be x1 plus x2, all divided by 2. And we have most of these x's. We actually do have the x value of the midpoint. That's given to be 3. Okay. And we also have one of the x values that's given to be 9. And remember, it's x comma y. And so if we do a little replacement, that's going to be 3, of course, is equal to 9 plus x over 2. This equation now we can simply solve, and that x here will be the other endpoint. Now, we have a suspicion it's going to be -3, so we can definitely check our work as we go. I know there might be some confusion on how to solve for this x, but first we just honestly have to deconstruct the equation. So first we have to deconstruct or undo a divided by 2. We'll accomplish that by multiplying both sides by 2. Multiplication kills division. Okay. And so we're going to be left with a 6 is equal to 9 plus x. Okay, so if we subtract 9, we subtract 9. The x value is going to be -3. Now, that is what we expected because we actually predicted that through counting. But I'm just trying to prove to you that you can solve the same thing using an algebra-based approach. Okay? We have to also solve for the y value of the midpoint. But again, that's just adding the y values together, then dividing by 2. And just like before, we have a bunch of that info. We know the y value of the midpoint's 1. We know we have a y value for one of the endpoints, so that's going to be 8 all over 2. And just like before, we can multiply out that 2. Canceling it out on one side, leaving us 2 is equal to 8 plus y. And then we subtract out the 8's. 2 minus 8 is going to be -6, and that's going to be our y value. But again, very predictable because we saw it there as well. And so the x and y value, so the x2, y2, shall be -3, -6. Now, do you have to do it both ways? Absolutely not. You can do whatever way you choose. But the point being, you have options, right? And so those last 2 questions in the notes, so please complete those in advance of your test on Thursday.